Good evening, guys. Today we are going to explain the code that we have used in our ML assignment, that is house prediction using machine learning. So in this code we have used in this project focus on implementing two algorithms, that is linear regression and decision trees, to predict the house prices based on key features such as area, number of bedrooms and bathrooms, age of the house, and its distance from the city center. This Python programming language, along with the libraries like Pandas, Seaborn, Matplotlib, and Scikit-learn, was used to pre-process data building models which evaluate performances and visualize the results. So let's move to the code part. Here we used Pandas. We have imported Pandas as PD, and we have imported sklearn model selection and train test split, and we have imported even sklearn preprocessing, standard scalar, linear model, linear regression as well, and decision tree regression. So here firstly we'll load the data set. So for that, first we'll define the pandas to read the CSV where we have exported our file house prices CSV file from our files. And next drop the we'll drop columns and errors. So from it will define like addresses, id. So we have used define is equals to df dot drop, columns is equal to id, errors is equals to ignore. So next we will define the features and target, whereas for x we'll define it as a input. So it will predict the price or number of bedrooms, bathrooms, and age of the house and all. So here y is defined as price. So for price part, it will detect the price of the house, which model will learn to predict. So next part will be continued by Kirtana.
Okay, in training test split, we divide our database into training, that is 80%, and testing is 20%, set using train underscore test underscore split. This helps evaluate model performance on the unseen data. And second one is linear regression, a basic machine learning model that defines a straight line relationship between input feature and the target. We train it on the training data and predict result for the test set. And third one is decision tree regressor, a tree-based model that makes prediction by learning simple decision rules. Like linear regression, we train it on the training set and predict test set values. And in evaluation, we evaluate both models using the R2 score, which tells us how well the model explains the various in the data. Higher R2 score means better performance. And at last, in conclusion, we compare that R2 score to decide which model performs better on the test data. Next slide will be explained by Shraddha.
So due to some technical issue, we have run our code again in the uh, collab. So the output of this code is that we got the two algorithms we have used in this output. The one is the linear regression and the decision tree recessor. These two models are evaluated using the following metrics. There are three that are mean squared error, mean absolute error, and R2 score. The R2 score, which is a coefficient of the determination, and mean squared error is also called MSE, and mean absolute error is also called as AE. In the linear regression, the mean squared output, like what error we have got, and even a mean absolute error what we have got. So in this mean, it is the average square of the errors, the average squared difference between the actual and the predicted values. In that between that we have used this for the formula that is used for mean squared error is 1 by n summation into yi minus yi cap whole square is the formula we have used in the case of MSc. So in this case we have got uh, it seems the last but It depends on the scale of the house price in the data. Example, if the prices are in lakhs or millions. So better is lower the MSE, where in the mean absolute error, it is something 2,26,806 point something. In the linear regression result, it is in it it is the average of the absolute difference between the actual and the predicted values, where the formula of the MAE is 1 by n summation of mod of yi minus caps cap by I. So MAE is 14,689, which means on an average the model prediction is off by 14,689 or the dollars. Oh, this is the quite price. Assuming the average house cost is much higher. So in the R2, it indicates how well the model explains the variability in the target variable in the range of 0 and 1, where 1 is the perfect prediction and 0 is the model explaining nothing, where the interpretations of that is R2 is something 0.0764 something so on till 127. Uh, the prediction is very close to the actual values. In the decision tree, the what is for the what we got for the linear regressions and MSc, the it is better to the lower the linear regressions in MSc mean absolute mean squared error, this suggests that the extreme errors are less frequent here in the mean absolute, where 26,000 for 26,042, which is the higher than the linear regression we have got. It indicates while the extreme errors or the fewer on an average, the decision tree is less accurate in the daily prediction. So in we'll explain it explains the 95.09% of the variance in slightly less than the linear regression. As you can see in this, where we have got first in the linear regressions result, that is about 72 triple eight 4.75235 of the mean absolute error, and in the mean squared error, sorry, mean absolute error we have got 226806.3571095757. So in that the R2 score we have got negative 0.076441676490691227. So in the same rather than in the decision tree regressor result, we have got something like more different from the linear regressions, as it is one in the mean squared error we have got 14238438248.16. So it is longer. Mean absolute error we have got something 316477.63, and R2 it is something bigger smaller than the linear regression, as the negative 1.121898105254887. So here the linear regressions is about like perform the better overall. The higher R2 is better at explaining the variation in the data in the final result. The lower ME is more precise in the general predictions, and in the decision tree might be better for capturing non-linear patterns, but it tends to overfit if not properly tuned. In the lower the MSc, as I said before, suggests the fewer large errors, but the higher average errors in the MAE. Uh, For the real world development, the regressions might be preferred here due to its simplicity, like interpretability and the consistently accurate performance in the dataset. So I'll next the whole conclusion will be given by Sharada.
Sir, I'm going to explain about conclusion. In this project, we treated to predict a house price using a two machine learning. One is linear regression and another one is a decision tree regression. We gave we gave her both model that same that about house, like for example area, number, and rooms, age, distance, etc., and asked them to predict the price is. After testing, we found two decision tree gave more accurate result than a linear regression. So even though linear regression is a simple decision tree work better for the kind of data where the relationship between a future and price is always straight. So the best model of the predicting house price is the project is decision tree regression. Thank you.